Welcome to the expanded presentation on technology and airline jet upset training. My name is Paul B.J. Ransbury. I'm the president of Aviation Performance Solutions. If you'd like more information on this topic, you can go to our website at apstraining.com/skies to download this article and other articles written by APS. First and foremost, loss of control in flight is the leading threat to air safety for air carriers. It's been demonstrated to be the most dominant threat to air safety over the past 10 years by the Commercial Aviation Safety Team. In this presentation, we're going to talk about two main areas. The first one is the instructor operating station, and the second one is standardized pilot knowledge applications. Within the operating station, or IOS discussion, we're going to discuss the overall presentation, how we assess whether the simulator is valid or not, how do we know when the airplane envelope is exceeded, and how do we actually observe as instructors when inappropriate control inputs have been made by the pilot in training. As we can see, loss of control in flight is the number one threat to air safety in commercial aviation. It's been persistent this way, number one or number two, for nearly 50 years. Recently, in the last 10 years or so, it has dominated the number one position because it's an area of threat that's not easily addressed by technology. It requires pilot intervention, training, knowledge, and skill improvements to address effectively. It represents nearly 40% of all fatalities in commercial aviation. Irrespective of the area of aviation you look at, whether it's general aviation, whether it's business aviation, or commercial aviation, the statistics chart has this shape, and today, in the past 10 years, loss of control in flight is the number one threat and the number one cause of fatalities in all those areas of aviation. In this discussion, we're going to talk about improvements to the instructor operating station. That means where the instructor is sitting during instructional training in the simulator, the presentations he's looking at based on what's being flown by the pilot in training is going to give him insights to what's happening, what has happened, and then understanding the fidelity of the simulator, the envelope, and how the airplane is placed in that envelope during the maneuver, the control inputs, and then a representation of what the pilot is seeing in the cockpit. And we can see this summarized here by the alpha, beta, angle of attack versus side slip, VN diagram, control positioning, which includes not only the side stick in this particular case, but also thrust position, flap configuration, speed brake use, and trimming, and very often autopilot modes across the top that we can see here. And this is a repeat of what the pilots are looking at in the cockpit. We are going to get into more details on this as we go through the program. The interesting part of this is that it's designed to help the instructor be more effective at delivering training, even if the instructor is fairly new to the domain of upset prevention and recovery training. We're going to talk about that a little later. The valid training envelope. Very important for the instructor to assess whether or not the maneuver that was just accomplished was valid, meaning did the simulator represent how the real airplane most likely would have behaved in the same situation. In simulation, there are three envelopes. There are flight test data, in other words, where the airplane actually went out and was flight tested in a certain combination of angle of attack on this axis, plus an angle from neutral of side slip, left or right yaw, depending on how the rudder is placed or how the particular flight condition is generating side slip. It doesn't always have to be from rudder. The next level out, this other box around the side, is wind tunnel testing, where they've taken the airplane into a wind tunnel and they've developed certain characteristics of the airplane based on that data. And then the extrapolated data is the engineer's best guess at how the airplane would fly at these increasing values of angle of attack and beta. For the instructor, it simply boils down to how close are the data plots to the flight test envelope. Probably in upset prevention and recovery training, the instructor is going to want to see at least the data inside the wind tunnel envelope to be fairly confident that is how the airplane would have acted in the same situation in the real world. Ideally, it should be within the flight test data, which is this solid line right here. And very often, with properly flown upset prevention and recovery training strategies and techniques, you'll find that even though the airplane will start outside, in other words, because of the disturbance, it's at an unfavorable condition of angle of attack and beta, that during a proper recovery, the pilot will tend to bring the airplane back into the heart of the envelope. And so based on which part of the envelope it's in, the fidelity of the representation changes. Inside this airplane shape data, flight test data, that's the highest reliability of the simulation. The wind tunnel is less reliable, but it has truly been tested, and very often the extrapolated data is the lowest likelihood that the airplane operated the way it would have in the real situation. But remember that the engineers are making an educated guess based on their experience and knowledge of how the airplane most likely would behave. And that is important for the instructor to know. Is the simulation that was completed valid? In this particular case, we can see that a lot of the maneuver was actually accomplished in the heart of the envelope. And what I mean by the heart of the envelope in this case is the heart of the fidelity envelope of the simulator, not necessarily the heart of the envelope or the operating envelope of the airplane. We're going to see that in a few minutes. If you notice the different colored dots, it is telling you if there's any kind of a limitation being exceeded. So in this particular case where all the green dots are showing, it doesn't mean that any type of operational limit is being approached, for example, like we see here in the orange dots, or has been exceeded like we see in the red dots. What it simply represents are the plots themselves here, is the accuracy of the presentation. The colors indicate to the instructor that there's something else to look at on another page. In other words, limits are being approached and exceeded that need to be noted in the proper delivery and briefing and debriefing of upset prevention and recovery training. This is an important envelope. This is where the instructor is going to be able to see how the airplane performed in a certain situation. In this particular situation, the airplane started at number 2. You can see the arrow progressing the airplane. Now it's going to start at a certain airspeed. Based on what we're looking at, I would say this is probably a nose-high airplane upset. We can't tell bank angle from this. That's another representation we'd have to look at. But we can see the airplane started at fairly high speed, and during the recovery, the airplane was unloaded, or G was reduced, and the airspeed decreased, which generally indicates a nose-high condition. Probably fairly nose-high because we go from 250 knots, and even though the pilot has done a nice job of unloading down to the half-quarter G area, the airspeed still gets way down here at about half of the 1G stall speed. Vs in this diagram represents the 1G stall speed. These curves represent the operational envelope of the airplane. This is the positive angle of attack limit, or AOA critical, or CL max, which is a flight envelope aerodynamic limit on the upper side of the wing. This is on the lower side of the wing under negative G. And then we have limit loads here. For example, limit load is 2.5 G in this particular situation based on the configuration of the airplane. Positive, -1, negative. And we also can see that it's showing where VMO is, and then we have VD and MD as well, which are maximum airspeeds that have been flight tested for the airplane. So the goal in this particular case is for the airplane to ideally stay within the envelope where all the factors are going to be green. Okay, in this particular case, we can see as the airplane unloads, as he gets slow enough, though, his unload isn't quite sufficient for the airspeed encountered to avoid the stall, which is what the red indications are here. The airplane just lightly touches the stall, and the length of the little line actually shows how much the exceedance of the critical angle of attack occurred in that particular plot. So it gives the instructor a really good understanding of the airplane with respect to the load limits of the airplane, the airspeed limits of the airplane, the angle of attack or margin of safety during the recovery, and then the combination of the maneuver to see how these parameters change to a point where there may be a debriefing topic. So in this particular case, because the airplane's flight attitude was so high, a debriefing point in this situation may be that because of this particular configuration, because of this particular situation or condition, is that unloading even more than the 0.5 or 0.4 G loading may have been merited or required to maintain more of a margin of safety. So in this particular maneuver, the pilot perhaps should have unloaded to a 0.1 or 0.2 G limit. And remember, we always want to stay at positive G in airplane upset. And the reason why is to maintain a margin of safety away from the critical angle of attack. So very, very informative of this diagram. But again, like the alpha-beta presentation, is we don't have the entire picture from one diagram, but we do have a lot of information. Margins of safety of load, speed, angle of attack. We have a real-time printout or indication of what the angle of attack is, so very, very powerful. And the exciting part is in the debrief, the instructor during debrief can actually scroll through each dot one at a time and look at all the various parameters on each of the pages we're going to talk about, plus some other data pages, to be able to not only understand what happens, but also to be able to give good information back to the pilot that actually is validated by looking at demonstrated values of performance in that particular airplane in that particular situation. So a lot of information. One of the hardest things when you're teaching upset prevention and recovery training, especially in an airplane here, for example, this is an Airbus cockpit presentation, for example, is what is the pilot doing on the controls, whether that be on the control stick in this case or the control column. And for example, like a Boeing airplane, what is the pilot doing on the rudder pedals? We have the rudder pedals here. What is he doing with the gear, the flaps? Where's the trim set? What's going on? Where are the throttles set? What are the modes of the airplane? Did he remember to disconnect the auto throttle on the autopilot? Was the stall protection on or off? Was a stall warning on or off in that particular situation? So as the instructor runs through the various dots through the program, or whether he's watching it real time, this representation right here will show the instructor what the pilot is doing in the cockpit. And anytime some kind of an exceedance occurs, is that the cockpit is going to, I should say the instructor operating station, or the area where the instructor is working, is going to flag areas to debrief. In other words, G limit was approached, G limit was exceeded, angle of attack margin of safety was approached, was exceeded, stall, extreme stall, or deep stall, depending on how the operator wants to define those. It is customizable for the particular operator in certain situations. So that was a look at how instructors can better understand the happenings and actions being taken during upset prevention and recovery training. This other pilot knowledge application is a tool by which pilots can prepare themselves with industry standardized and vetted information to be prepared for the very simulator session that the instructor was analyzing. This is an iPad application that's been developed by Aviation Performance Solutions and International Development of Technology on upset prevention and recovery training. And in this particular design, it is very clear on what is industry vetted information. Everything above the line is industry vetted information except for the video streaming in here. This is just some interest items, for example, with airplane accidents analysis reports and some other things. But module 1, 2, 3, all the way through 8 are industry vetted concepts presented in the airplane upset recovery training aid for pilots to know that they are looking at material that's been through the industry and expected for them to know. Airlines, for example, can customize this to their brand for color and logo, but also down here, they have the opportunity of customizing the app for their particular application of UPRT, or upset prevention and recovery training. Perhaps they want to include HUD training. Perhaps they have their own set of standardized techniques or procedures. Perhaps they have their own training mission profile that they want to load in. There's all sorts of variations that they can do, but they have control over what goes into the particular application for that airline or for that flight department. So very powerful, an airline can make it their own, but the nice part is the instructors and the participants or the pilots always know what's vetted information by industry or the standardized information and what is unique to their particular airplane, which may very well augment this information, but they're not mixed together. So very, very powerful. It's self-navigating. It's easy to navigate. There's drop-down menus, change the font size. There's audio narration on, off. There's other information being presented. Very, very easy to navigate. Each section you can take the exam, and based on how you do, it can be showing that the exam was passed or the exam was not passed. When all 8 modules are complete and the exams are complete, then the pilot can print out their own certificate that gets emailed to them. So a very, very powerful application. So that is an overall summary of a few advancements in technology in airline upset training, and I really enjoyed taking these few minutes to talk to you about it. If you want more information, please visit our website at apstraining.com. Have a great day.